Hi, welcome back to Module 3 of Artificial Intelligence of Things. Here in this module, we'll be talking a little bit about the AI portion and specifically some practical exercises as well as application areas for AIoT. So here are the slides. This part will be mainly focusing on the practical as well as the practical exercises and the application areas. So this is actually module 3 of a 4-module series, and this is actually the major portion. So as we have talked about the outline in the previous video, for this section, we'll be talking more about the practical exercises. Please point out practical exercise as well as the application areas of AIoT, industrial IoT context, in smart cities context, and also in home IoT and personal IoT context. So we will be looking at a tool called the Azure Machine Learning Studio. There are actually two versions of this tool. The first version, which we're going to look at for our practical exercise, is actually the Azure Machine Learning Studio Classic. It is called Classic because it is the original version and it's actually available for free for use. Whereas the new version is actually a commercial tool that's available on the Azure cloud, but it's also called Azure Machine Learning Studio. So to distinguish between the two, they have named the old version Azure Machine Learning Studio Classic. So if you enter the URL here, you will enter into the Azure Machine Learning Studio Classic screen. So I will go through the slides first before going through a lab exercise with you using the web. So this will be the first page. If you click on the link here, you will log in into the tool. This is basically the login screen for the Azure Machine Learning Studio Classic. So what I intend to do is actually to go through the slides first, then show it to you on the actual application itself. So the Azure Machine Learning Studio interface is actually really drag and drop. There's no need for any coding at all. It's a web-based interface, and you just click and drag the application, interact with the application itself. There are actually many pre-built algorithms like the K-nearest neighbor, support vector machines, the artificial neural networks, and decision trees. They're all pre-coded. So there's no need for you to implement any of these learning algorithms in code at all. Not a single line of code needs to be done, just drag and drop interface. Now, if you do not have any sample data sets and you do not want to look for it and you want to upload them, no problem. There are actually some readily available sample sets, some classic ones available for learning purpose. Now, for those more advanced users who actually want to use some R coding or Python coding to do some modification or enhancement to the algorithm, you can do it. It will support integration with R and Python, but it is ready for more advanced users. It's not actually required for normal users to do this, but if you are interested, you can do it. So you can also find all the documentation online as well. And one interesting thing is that actually there is a one-click deployment to web service. So if you remember for model deployment, from the train model, we can actually export it to a server, and any request is just sent to the model. We do not need the original training data because the model itself is already the program that has been built automatically from the data. So what happens is that in the case of Azure Machine Learning Studio, Microsoft actually generates the code, the surrounding code for the service itself, and it will deploy it to the Azure cloud automatically for you. So you don't need to write a single line of code. All you need to do is to do the modeling, and once you build the train model, it will be able to generate the code for the service for you. So the documentation is online. You can just use the URLs to get it. So what are some of the things that you can do with Azure Machine Learning Studio? It supports regression, which is predicting a value. it supports classification algorithms. So two category, if it's two categories, it's a two-class classification problem, such as predicting whether a customer will renew their service, yes or no. But it does also support multi-class. That means more than two-class results. If it's yes, no, maybe, the algorithms called multi-class classification algorithms as well. It can find anomaly or unusual outliers in the data. So this is good for example, for cybersecurity type problems to detect some unusual data. It can actually have unsupervised learning as well. So customer segmentation, grouping similar customers together is supported. So there are algorithms for unsupervised learning. So if you click on the link and you want to go in, you actually need to have a Microsoft account to actually use it, and it's actually free, $0 a month. But if you do not want to actually sign in with your email or create an account, you can actually still use the guest workspace. But bear in mind that if you use the guest workspace, some features are disabled. For example, you cannot upload any of your own data. It is just for trying out the interface. You're not able to download or save anything from this account. And after 8 hours, they'll be automatically wiped. So to access this particular page, what you need to do is to click on the, instead of signing, here you need to have an account. You can click on the sign up here, and it will actually bring you to that page where you're given a choice still to sign in, or you can actually create one if you want to be a paid user, or you can just enter as a free user. Now the price is free, and they actually give you 10 gigs of data space just for that free access. For the signed in user, you cannot use the guest account workspace one. That one doesn't come with any storage. So then at navigation, so you find that actually once you log in, you will come to this main page, and the experiments tab is a tab-based interface. So you can actually move between the different tabs. So the main one is actually the experiments, where it stores all the different workflows. So in Microsoft Azure Machine Learning Studio, it refers to these workflows that you generate for machine learning as an experiment. So you can see that this is very similar to what you see in the data professor's workflow. You have data flowing in from the top, you do some processing on it, then you split the data, and then you have the final training and the evaluation. So later on, I'll show you how we do that in the web interface itself. Now, just notice that at the bottom, we have some menu. So this is actually taking the place of what is normally at the top left-hand corner. The normal file menu is actually at the bottom part of the screen in Azure Machine Learning Studio. But besides that, it works very much like any other web application. So you can find other things like some sample examples in the gallery. If you click on the top left-hand corner, but you will get the standard file, new file, create something kind of menu options up there. It just goes to different parts of this Azure Machine Learning Studio applications. The gallery is actually some sample examples of how to do various common things, and it's quite useful for beginners as well. So how would you actually import data? Now, oftentimes when we do a new machine learning experiment, we may not have the data on hand, and we may actually need to look for the data. So one of the things I always encourage users to try to do is actually try to look for public data sets first, because if the public data set is available, you save the time and effort to actually collect your own data. And it's likely to be closely related to what you're interested in anyway. So there are a number of tools that you can use to search for data. For example, the Google Dataset Search Toolbox. You can enter it, and it will actually bring you into the dataset search interface. You can see that the URL actually has changed recently to something that is more closely. They have changed the name. Okay, so it's dataset. But if you enter the URL here, it will still go to the same location. So I'll show you a little bit of a demo about how to do this later on. Another place that you can find some data is actually at the UCI Machine Learning repository. Here, the data has been already pre-classified into different types of problems, such as classification or regression. So it's actually quite useful for learners to come here to try to find some data set they can use for learning purpose. And you can find many public data sets, already pre-categorized, pre-clean, available here. Now, once you actually log in, you will be able to also find this tab interface. If you click on instead of experiments, which has all the workflows, you click on another tab interface, which is data sets. You find that you can actually click on the bottom to create to upload the new data set. So click on that, just select the data that you have downloaded and click on yes, and it will go and it will upload. Now, the way you create a new workflow or a new experiment is the same. You click this on this tab, and you click on the new below. Notice that the menu is actually at the bottom. It's not at the top. So all the file new type menus are actually at the bottom. Click on the blank experiment, and you will come into this screen. So initially, we totally empty. So this is actually a very visual interface. The idea here is that the main working area is the canvas in the center. And on the left-hand side, you see a palette of tools. So the way the interface works is that you can just click on any of this and just drag, left click on what you want and just drag it onto the screen, then let go, and you will actually be there. Anything that you select, the properties of that will be shown on the right-hand side. And you can see the file menu will be the same. File save as is, or save is actually below. So for example, I click on this blood transfusion data and I drag it in. It will appear on the canvas, and if it's highlighted by you clicking on it, it will be highlighted with a blue line. And you can see when it's highlighted, the properties associated with that object will be actually on the right-hand side. You can zoom the controls in and out. I'll show you how this is done later on as well. And that actually comes to the end. So after this, I will go into the web interface to just demonstrate the same steps that we've seen on the slides, and just show you how it actually works. So here's the first URL, the Google data set search. So here again, the idea is to actually search for things that you want to investigate, but you don't have the data, and you have two options. You can go and collect your own survey data, or you can try to trawl around in your database. But there are also many public data sets that's available beyond those two examples that I mentioned earlier. So for example, coronavirus or COVID-19, there are many data sets that people have collected around the world. So you just do a search, you can find all the different data sets, okay, like who owns the owner, what's the format, how large is it, the date, etc. So the one that I want to look for, like blood donation, you can also just do a quick search for it. Okay. You can see so many different. So this is the search engine specifically for data sets, rather than just for the general information that the normal Google search engine would return you. So it's really just intended for different files and databases that on a particular topic. And it's quite effective in finding many of them. Let me just go back. So let me just zoom out a bit. So this is the one from the UCI machine learning repository. I've done a search for blood donation, and it actually brings me to this page. So you can see that it will again document all the data that you have, and there's some description here as well about the data set. So normally a data set that you want to use, you have to try to investigate where is it, how long ago it is. So this was actually not too long ago, 2008, by Professor Ye in Taiwan. And we are going to use this data set for our lab practical afterwards as well. So the idea here is to use what we call the RFMTC marketing model. And it's actually a generic marketing model. It's not just meant for blood donations, but it's actually meant for any particular industry, and it's been used across many different industries as well. But you do need to make some modification to the meaning of the variables you use. For example, if you use weeks instead of months, it's still a measure of time. So the idea for this experiment is really a very common problem that most blood donation centers around the world actually face, and that is they find that actually they want to encourage people to donate blood, but they do not want a case where they try to market to everybody and then spam everyone with this blood donation drive. So the idea is targeted marketing. Targeted marketing. You want to only send the request or the marketing material to encourage people to donate blood only to those people who are likely to donate blood. So how do you actually determine whether a person is a potential donor or not a potential donor? So if you look at the data set here, we have some information collected, and this is where the RFMT is used. Recency is actually how long it has been since the last donation, right? So it's actually a freshness factor. So if the user has been donating blood up to just 1 or 2 months ago, it will be reflected here as a very small value. Frequency is the consistency factor. How often did the person actually donate blood? Monetary is actually the value or the dollars, right? So some folks will think that dollars is the money talks. So the notion of value or money varies with the model, right? So in the case of blood donation, obviously the value is in terms of the total amount of blood donated or in CC. But if you're talking about educational context, let's say I want to market educational costs, then that monetary value might be not CC, but maybe the marks that the students get or the grade the students get for a particular exam. That's the currency that the students or the money that the students will understand rather than CCs. So you need to modify the variables according to the industry or the business context that you're working on. And time is the loyalty factor. How long has it been since the very first time the person has donated blood? If the person has been donating blood for a very long time, means that he's a very loyal blood donor. And the last one is actually the target variable, the label that we're trying to predict, where 1 stands for the person is the likely donor, and 0 means that the person is unlikely to respond to your blood donation drive. That's 0, right? So the idea here is to make use of the RFMT to try to predict what is the target variable. Is it 1 or 0? Because you want to actually send out your blood donation drive to all those who are flagged out as potential ones, and not to waste your time on the potential the zeros that you predict. The ones, because they are not likely to donate blood anyway. If you look at this data, you might think that, hey, maybe recency is the most important or frequency is the most important. But, and when I ask students, typically they will come up with different answers. But the things that they haven't even seen the data. So this is actually a learning point for most beginners. Try to keep an open mind, because before you examine the data doesn't really, you can't really tell, right? But each of us has a bias. All of us have our own bias because of life experience. So some of us feel very strongly that, hey, actually monetary is the most important because money talks. Others feel that loyalty is the thing, right? You must be a loyal person in order to be counted as a potential blood donor. That's actually all of us reading our bias into the problem itself. So you need to keep an open mind. Let the data speaks for itself to see which is actually the one that actually will donate blood. So the problem is this, okay, trying to figure out all these variables, which is actually one that actually potentially will affect the donor status. So let's go into the experiment. So if you log in, you will come into this main screen where you have all this data. Oh, I've got one thing. So if you can actually download the data in the data folder, and I have actually pre-downloaded this, so I'm not going to actually, so the data is actually contained in the transfusion.data. So if I want to upload data, I go to data sets. I click on the file new below. I choose the file, so just find where it is. And I've actually downloaded it onto my desktop. And it is actually a CSV file with a header. So just click yes, and it will upload. Once it's done, it will be shown on the screen, and there will be a green tick saying yes, it's okay. The okay comes out. Right, so all this, so you can see the data is there already. So it's called transfusion data. I didn't change the name from the file name. So in my experiment, I want to create a new workflow. I'll click on the file new down here, click on the blank experiment, and it will generate. So actually it's a drag and drop interface, as I mentioned before. So this main part here is actually the canvas, where all your things are going to be dragged in. So I'm going to look into my save data section. Just now I forgot to rename it, so it's still transfusion data, unlike the slides. But it's the same data set. So it's just left click, use the left mouse button, click on it, and just drag it onto the screen. Once it's dragged onto the screen, it will appear here as what you have, right? And I can then, if I click outside, the properties will just show the general properties. But if I select it and it's highlighted, you can see that the information will be there, and you can move it around. And it was so there's a zoom in, zoom out interface as well. Now there's actually a mini map to help you move around quickly, but when the screen is actually still quite doesn't have that many things, it's not so useful. Later on, when I show it to you, when there are more things on the screen, it will be more apparent what this mini map actually does. But at the moment, it's not so obvious. Okay, so that would be the main interfaces for this. Okay, let's start once again. So you can see that you can actually edit the name of the experiment. So I'm going to call it blood donation experiment. And you can also click on save to save it later. But yeah, I'm able to do that at the moment because with just one widget, it won't allow me to save yet. Right. So most of it is left click to activate various things, and you can drag in more things onto the screen. So you can actually have multiple versions of the photo. Let me just drag in some other stuff like summarize data. So sometimes it's very difficult to look for what you want. For example, I can actually put in more example data sets. I just want to show you what the mini map does. So you can see that where there is more examples, it will, when you zoom in and out, it will be helpful to have the mini map. You can also reset to one-to-one size. Let me just remove this one first. Okay. Let me just remove this. So you can just select all of them. You can just click, select multiple, and all of them are highlighted. You can just click on the delete key, or you can right click on the action. So some actions are actually done by left click. Most of the navigations are done by left clicking. But if you want to do some things that's specific for the tool itself, you can right click and you can just select delete. So it's just all remove. Okay. Now you notice that actually for this kind of tools, there are these brown knobs that you see. So the ones that are on the bottom surface actually outputs. The one that appear on the top will be input. So the data is always flowing out from the output to an input in the next widget. So the data flows downwards only. It doesn't really allow for simple. That's just the convention that they have. Okay, the data flows in the downward direction. So the outputs are always at the bottom. Now, if you want to examine this data, you can just right click on it and you can select, you can actually download the data set for your own analysis later, but we're not going to do that. We're going to just click on visualize to just take a look at the data. So and the first step in most data process machine learning workflow is ready to do some exploratory data analysis. Now, I would say that actually for Azure Machine Learning Studio, its analysis capabilities are quite limited, right? But you can still do some of this just to do an initial check on the data itself to see some patterns in it. So the idea here is that you have all the different columns of data, and we want to see which of these columns of data are likely to actually affect the donation status, whether or not the person is likely to donate blood. And some of us will think that it's recency, some will think it's frequency, some think it's monetary, and others think that it's actually the loyalty factor. But we don't know until we take a look at the data itself. So let's take a look at first of all, whether or not the data is balanced. So we select this last column to actually show you the balance. And you can see that most of the people actually did not donate blood, but there's a fair number that also donate blood. So although it's not totally balanced, It is 50-50, but it is not so imbalanced that you need to be extremely worried about it, right? So there's a good 1/3 that will actually donate blood. So still reasonable enough for us to work with. Now we want to actually see which of these are actually related to this the tendency to the response variable, right? The target variable. Which of these other columns is related? So let's check recency first. Okay, so we compare the target variable with recency. You notice that for 0, that they will not donate blood. It's actually associated with very large recency. That means if the person, it has been a long time since the person has donated blood, you find that there's actually nobody with such large recency that would actually donate blood. So there's a very clear line that above 30, right? Almost all members are going to be in the 0 category. That means, so it looks like recency is probably a good predictor in a negative sense. That means it's a very large value in recency and it has been a long time. It's not so frequent, right? No, not so fresh. Then it's very likely that the person will not be a blood donor. But if it's a more recent period, it can be in either category. But at least for large numbers, it is definitely in the non-blood donor category. Let's compare with frequency. For frequency, you see that it's sort of mixed, but you do see that if the person is donating more frequently, right, large numbers, they're actually more on there's more likely to donate blood as well. So again, it's possible that for larger values, it does give us a good indication that the person will donate blood. Let's check with monetary. Again, for larger values, there seems to be more, the 2 zeros here, but many more that will actually donate blood. So monetary and frequency also seem to be quite, they can be possibly good predictors, but we'll take a look at a statistical check we can use to determine that for sure later. But from a visual point of view, when we do this exploratory data analysis, typically we are doing it from a more visual manner. We find that, hey, actually looks like the data is not too bad. We can actually get a good idea. And lastly, the last factor, time. So it looks like loyalty is very mixed, right? So for large values and the entire range of values, right, it can be 0 or 1. So when you see this kind of pattern where it can either be 0 or 1, regardless of the value of time, whether it's small or large, it just indicates to you that really time probably is not a very good predictor of the target variable, right? It really doesn't determine whether the person will donate blood or not. So because it's very, very mixed. Okay. So this first, of course, other tools that you use, it can probably give you a better analysis in terms of the exploration. But for Azure Machine Learning Studio, at least you get this very simple interface that you can just explore first, right? So you can also don't compare this, and if you click on the different columns, you can also see the distribution that for recency, most of it you are actually in the low values, but you have some large values, so it's a bit skewed. Frequency, again, more of the lower values, but there's a long range of smaller numbers of large values. Monetary too, and time in months is at least more evenly distributed. So you have large, small values as well, fairly representative numbers of large values. So we may need to actually do some adjustments to this because of the skew, because skewed data is where there is a lot of in one range, but the range actually extends to a very large, larger values, but the frequency is actually very low. So one of the common transformations is basically to do a log. So if you log it, it will actually try to make this into a more evenly spread distribution like this. But we're not going to do that for this experiment, just to keep things simple. So with that, I have just shown you what we can do in terms of exploratory data analysis with Python. So not with Python, with the Azure Machine Learning Studio. If you want to do something more sophisticated, you probably need another tool like a Python programming to actually plot out the graphs in more detail. So one last thing which I want to tell you is that you notice that actually it will display some of the columns of data, and looks like the data is fairly clean. There are no missing values, but it does not show you the entire range of values. Okay, there are 748 rows of data in total, but what's actually displayed on the screen when you right click and visualize is probably only the first 200 rows. maybe from 201 onwards to the end, there's actually some missing data, right? And you can't be sure that there are no missing data. So later on, I'm going to show you in the next set of videos how that we can do a quality check, what we call a data audit, or summarize data to just check on the quality to see whether or not, if you look at the entire set, whether there are missing values, whether there are also extreme values or outliers that we will observe in the data. Now, for this data set, it's actually fairly clean, so there's not much in terms of outliers or missing data, but we just want to make sure that there really isn't. Now, in a real environment, when you have data sets like this, it's okay. If you have 200 rows, you can probably use your eyes to check, right, for outliers or even missing data. But let's say you have 20,000 rows. You can't use your eyes to do that, right? You go blind, trying to look for the missing values in 200,000, 20,000 rows. And if you have multiple columns, not just 4 columns, but 100 columns of data, again, trying to look for it manually with your eyes, is just not the way to go. So we do actually need tools to help us to automate the data quality check. The plots can be used with more data, but if it's into the millions of rows, and then basically the plot, you also need to do something because you can't plot a million points. The time taken to do the plot will just be too long. Okay, so there are various tricks that you would probably need to employ when the data set is larger. And the Azure Machine Learning Studio doesn't have those in it. It's not built for that purpose. It's meant for more learning and for you to prototype something. It's very quick for prototyping because what you have is a tool that you can just drag and drop. So any algorithm you're going to try, you can just drag it in, and there's a whole long list of algorithms in the machine learning portion. You can see many, many different types of algorithms for classification, for regression, for clustering, for etc. So many, many different algorithms, and you can just drag and drop them into the canvas and experiment with it without having to write any line of code. So actually, even for myself, I often use this tool just to do some initial prototyping, quick prototype, so that I know roughly the direction I should go. Try out some of the algorithms to see which actually work better with the data, or maybe a sample of the data I have before I actually write code to actually do a deeper examination of the data. So that's about it for this series, this part of the video. I'll come back again later on in the next video to tell you a little bit more detail about how you can prepare the data. So thank you for your attention. I'll see you in the next video.